Welcome to Lesson 4.1. Today we're going to talk forms of proportional relationships. Our learning objectives for today: you'll understand relationships that are proportional and non-proportional using the formula y is equal to kx, and you will understand that a proportional relationship can be graphed with a line through the origin whose slope is the unit rate. Here's our introductory problem. Make sure to take a few seconds and read this before moving on. So a ratio represents a comparison between two quantities. We can write ratios in fraction form using a colon or using the word to. We've covered that before. We've also learned that equivalent ratios are two ratios that are equal. The numbers in the ratios may not be the same, but the comparison of the quantities is the same. Equivalent ratios are directly related to proportions. So what is a proportion? A proportion states that two ratios are equivalent. Here's an example of a proportion. 1/2 is equal to 2/4. This proportion shows that the ratios 1/2 and 2/4 are equivalent. In other words, a proportion is made up of two equivalent ratios. In the situation above, we know that all of the parts of the two ratios that made up the proportion. Sometimes we will know 3 of the numbers, but not 4 of them. When this happens, we have to use a variable and solve for the missing number. Look at this proportion. 1/2 is equal to n over 12. Notice that the first term in the second ratio, or the numerator, is a variable. Suppose we wanted to find the value of this variable. We could do that by using proportional reasoning. Proportional reasoning is when we figure out a missing value in a proportion by thinking about the relationship between the numbers in the two ratios. So we're going to solve for n. So what we do, we've got this proportion right here. If you look at our bottom numbers, 2 to 12, what do I need to do to 2 to get to 12? Well, I need to multiply by 6. So because of that, I need to do the same to the top. So I need to multiply the top number 1 by 6 to get n. So n is equal to 1 times 6, which is just 6. Here we have another proportion. We got 2/3 is equal to a over 9. Okay, so when we do this, again, what do we multiply 3 by to get to 9? Well, we multiply it by 3. So I need to multiply the top number by the same thing. So a is going to be equal to 2 times 3, which gives me a 6. Here's another proportion. We've got 2/5 is equal to b over 20. Again, what do we multiply the bottom number to get 20? So 5 times 4 would get me 20. So I need to do the same thing on the top. So I'm going to multiply 2 by 4 to get b. So b is equal to 2 times 4. So b is equal to 8. So now we're going to write proportions, and we have to be comparing items of the same units when we do that. So let's try that together. Each spring you plant 60 carrots in your vegetable garden. Not all the carrots survive until the end of the season because they are eaten by a rabbit that also lives in the garden. Therefore, by the end of the season, you usually harvest around 45 carrots for eating. The following year, you notice that the rabbit in your garden has had babies. Do you think the amount of carrots will increase or decrease with the increased number of rabbits in the garden? Well, if a rabbit eats about 15 carrots, and all of a sudden there's more rabbits around to eat more carrots, you are going to probably have a decreasing number of carrots at the end of the garden. One week you go to the store and buy 3 apples. The following week you go to the store and buy 8 apples. Assuming that the price of the items remain the same for both weeks, which week do you expect to spend more money on groceries? How do you know this is true? So we're buying 3 apples one week and 8 apples the next. Assuming that they cost the same both weeks, if you spend the same amount on 3 of them as opposed to 8, you are going to spend more on that second week when you buy 8, because you're buying 5 more apples, so the price is going to go up by whatever the apple costs times 5. So now we're going to use that to talk about linear equations, especially those in the form of y is equal to k times x. The y and x are variables are said to be directly proportional to one another if it's in that form. And k is the proportionality constant, which has the units of y divided by the units of x. For example, if x is the pound of beef in a package at a butcher shop and y is the cost of the package in dollars, then k would be our price per pound. This equation shows that as the value of x increases, the value of y also increases. For each unit change in x, the value of y will change by k. So if y is graphed against x, a straight line will have a slope of k. If we take 5 packages of beef from the meat compartment and plot the cost of y axis versus the weight, which is x-axis, then all 5 points should fall on a straight line with the slope being the cost per pound, as shown in the plot to the right. So if we look at that, okay, if we get a half a pound, it costs $3.49.5. If we get 1 pound, it's $6.99. 3 pounds, it's $20.97, 4.5. Okay, so to find K, okay, we can divide both sides by X. So K is equal to Y over X. So all I need to do now to find my K is to pick one of them. So this one right here. 3.495 is my Y value divided by my X value of 0.5, and I get that my K, or my slope, is 6.99. Okay, so that's how we would find our slope in this kind of problem. So the engineers involved in the design of irrigation system need to know the relationship between evaporation rates, or we're going to use that as E in millimeters per day, and the air temperature T in degrees Celsius. Assume that for a given geographic location, the following equation applies. E is equal to 0.25 T. So what does this equation indicate? And if E were plotted against T, what type of plot would result? Okay, so let's look at the first question. What does this equation indicate? Okay, that means that E, which is in millimeters per day of evaporation, can be estimated if we know the temperature in degrees Celsius. Okay, so that's what this equation indicates. We can find E if we know T. We also know that as T increases, E will increase. That means that this is a proportional relationship. Okay, because if I start plugging in values of T and I get my T values going bigger, my E value will also be getting bigger as well. And we can show that with the table. So if we plug 10 in for T, so if I did 0.25 times 10, I would get 2.5. So at 10 degrees Celsius, the evaporation rate is 2.5 millimeters a day. If I did 20, so 0.25 times 20, I would get 5. So the evaporation would be 5 millimeters a day if it is 20 degrees Celsius. Same thing with 30, I would get 7.5. So as you can see, as my T values get bigger, so do my E values. Okay? And you will notice again that this is going to be a linear graph. So that would be the type that is plotted. It's going to be linear. So now we're going to bring back that y is equal to kx equation. And we're going to say that k is 6. So we've got this right here. We're going to solve this equation for the k variable. So I want to get 6 by itself. So I divide both sides by x like I did before. So I've got 6 is equal to y divided by x. Okay? So now we're going to find an x and y value that makes this equation true. Well, what value divided by what other value would give me 6? Well, the easiest one to find would be 6 divided by 1, because 6 divided by 1 is 6. To get another one, I could do 12 divided by 2. Okay? And if you'll notice, if I take those two fractions, you will notice that I can multiply the two numbers by 2 in both to get the other one. So those are a proportion. Okay? So those are proportions. And that would be true for any values of y and x that when we put it divided by, and we would get 6. So we could set them all equal to each other, and they would be proportional. The cost of land is $7,500 per acre. So we're going to write an equation that shows the total cost of land, C, for a given acreage, A. So to find the cost of the land, we take the acres and we have to multiply it by 7,500. So this would be my equation. So C is equal to 7,500 times A. They want to know if the relationship between the total cost and the area of a piece of property is directly proportional. So area, and cost. So if it's directly proportional, that means that as A goes up, C also goes up. So if I buy 1 acre, that's going to cost me $7,500, because if I plug 1 in for A, I'd get $7,500. If I bought 2 acres, that would cost me $15,000. If I bought 3 acres, that would cost me $22,500. So as you can see, as A goes up, so does C. It is directly proportional. So as we talked about, directly proportional means both values are increasing. So inversely proportional relationships is going to do the opposite. Okay, so one of them is going to be increasing while the other one decreases. And the equation that we use for that is a little bit different. It's y is equal to k divided by x to start out with, instead of y is equal to k times x. So as y is graphed against x, the slope is not constant. The graph will be curved with a negative slope. This equation is sometimes written as y is equal to k times x to the negative 1, where the negative 1 exponent indicates that x and y are inversely proportional. Okay, so there's an example down below. Make sure you read that before moving on. Okay, so what does that relationship indicate that you just read? So if we had plugged in a 2 in for that equation, okay, we'd get 122 divided by 2, and we would get 61. Okay, so the average length is 61 centimeters. If we plugged in 5, 122 over 5, we get 24.4. So you'll notice, here's my x, here's my y, here's my x, here's my y. As my x value got bigger, I went from 2 to 5, my y value got smaller, going from 61 to 24.4. Another way by looking at this is by solving the equation for k. So again, we take a look at y is equal to k divided by x. So to get rid of the x, we multiply everything by x. So y times x is equal to, and here the x's will cancel out and get k. So since you know that k is a constant, that means that it'll always be the same number. That you can see that for the value of k to stay the same, the value of y must increase if the value of x decreases. The opposite of also is also true, so y would have to decrease if x gets bigger. So again, we're going to use the value of 6 for k, and we're going to solve for 6, so we're going to multiply both sides by x again. So we get that y times x is equal to 6. So now we're going to again solve for x and y. So what two numbers can multiply together to get 6? Well, I could have 1 times 6, or I could have 2 times 3. So again, here's my y, here's my x, here's my y, here's my x. In this particular example, my y values got bigger and my x values got smaller. Okay, so they are inversely proportional. So a review, if an equation shows a directly proportional relationship, x and y values will be directly proportional. It means if one goes up, so does the other. A proportion must have an equal sign between the comparisons of two ratios. Direct variation is when one variable changes, the other changes in proportion to the first. So if one goes up, so does the other. Inversely proportional relationships are in the form of y is equal to k divided by x. As either x or y increases, the other one decreases. A proportion is a statement in which two ratios are equal. A ratio represents a comparison between two quantities. We can write ratios in fraction form using a colon or using the word to. Equivalent ratios are two ratios that are equal, and a proportional relationship between two quantities is one in which the two quantities vary directly with one another. If one item is doubled, the other related item is also doubled.